In just a brief moment, a Russian turtle tank on the battlefield changed from the image of a heavily covered vehicle built to survive into a target trapped in the open. At first glance, it might have seemed like just another Russian vehicle running into trouble at the front. But what made this scene more striking was the fact that this vehicle had been built to endure the very kind of war now dominating Ukraine. Its added armor, steel framework, and entire heavy shape showed that this was no longer an ordinary tank. And yet, the moment it was held in place in the open, the whole meaning of that protection began to come into question. So what exactly caused this turtle tank to become locked in place on the battlefield? And after it was trapped there, what happened next that gradually made all of its outer protection lose its meaning? Let's take a closer look with military force. The first decisive turn in this clash came when a Russian turtle tank moved into the combat zone under the protection of cage armor and heavy metal framing. It was the kind of vehicle designed for a battlefield where survival depends not only on steel, but also on resisting threats from above. Its strange shape suggested preparation for a new kind of war. Yet that image of strength lasted only until the vehicle reached a mined area and was abruptly stopped before it could complete its assault roll. The explosion did not need to destroy the tank to change the outcome. It damaged the tracks and removed the crew's ability to move forward, reverse, or turn away from danger. In open terrain, that loss was critical. A tank that cannot maneuver no longer controls distance or timing. It stops being the side that presses the attack and becomes the side forced to wait under pressure. That is why mines remain so important in a war shaped by drones and precision fire. They do not always kill the vehicle outright, but they can strip it of the freedom that makes armor useful. In practical terms, the blast transformed a moving assault vehicle into a stranded object. From that instant, the crew was no longer trying to seize ground. It was trying to survive exposure in a place where delay usually invites greater danger. Once the turtle tank was pinned in place, its extra armor no longer offered the same advantage. Protection can reduce risk when a vehicle is still moving and choosing its path. It becomes far less valuable when the vehicle is fixed in the open and visible to the enemy. At that point, every second begins to work against the crew. The tank is no longer an assault platform shaping the battle. It is a target waiting for the next step in the attack cycle. This is what makes a mobility kill so important in the current war. The vehicle may still appear intact from a distance, but much of its battlefield value has already been lost. Initiative disappears first, then options disappear with it. What remains is a machine that still looks dangerous, yet has been pushed into a far weaker position. For Ukraine, that frozen moment marks the shift from blocking an advance to hunting a trapped target with greater purpose. The turtle tank was not defeated only because it stopped. It was defeated because once it stopped, the logic of the battlefield turned fully against it. The armor around it could delay damage, but it could not restore movement, and without movement, the vehicle had entered the most dangerous phase of the engagement. Once the Russian turtle tank had been immobilized, the nature of the threat changed at once. A vehicle that is still moving can complicate an attack by shifting direction, changing speed, or forcing drone operators to make fast corrections. A disabled vehicle loses that advantage almost immediately. It may still carry armor and weapons, but it becomes far easier to study under pressure. That is why the Ukrainian FPV teams did not simply rush toward the thickest metal they could see. They treated the tank as a technical problem on the battlefield. Their aim was to find where the improvised shell weakened, where protection ended, and where a carefully guided strike could achieve more than repeated impacts on the strongest areas. This is what makes the next stage so revealing. Turtle tanks are built around a simple idea. If drones often attack from above or from exposed angles, then layers of metal cages, sheet covering, and outer framing can reduce the chance of a clean hit. In some situations, that protection can help. It can spoil the angle of impact, absorb part of the explosive force, or stop a drone from reaching the hull or turret directly. But improvised protection also creates new limits of its own. It adds seams, bars, corners, and spaces between surfaces. In real combat, Those details matter. Every irregular edge can become a guide for a skilled operator who is looking not for the strongest point, but for the weakest path into the vehicle. That is exactly how Ukraine's FPV crews appear to have approached this kind of target. Instead of spending drones against the most reinforced sections, they searched for gaps between added plates, openings inside the outer frame, and areas that no field modification could fully cover. The first strike in such a sequence does not always need to destroy the vehicle. It can expose a flaw, tear away part of the added structure, shake the crew, or show how the armor has been fitted together. Once that happens, the next pass becomes more informed. Pressure grows not only through damage, but also through knowledge. Each approach gives operators more visual detail, and that allows later strikes to aim at points where the protective shell no longer works as intended. When fire finally breaks out inside the vehicle, the lesson becomes clear. The armor did not fail everywhere. It failed in one place, and one place was enough. That result says something important about drone warfare in general. FPV drones are not heavy missiles built to overpower armor through sheer explosive force. Their main strengths are accuracy, timing, and the ability to attack from angles that traditional ground fire cannot always reach. Because of that, the question is no longer whether a vehicle can stop one direct hit on its thickest point. The more important question is whether it can deny access to every small opening that a maneuverable drone may exploit. On a battlefield, that is extremely difficult. Field armor is often assembled quickly, with limited time and uneven materials, so it rarely forms a perfect shell. In that sense, the drone is not simply a weapon that strikes. It is also a tool that tests defenses, maps weaknesses, and turns every failed layer of protection into guidance for the next attempt. That cycle can unfold within minutes during contact. That is why this episode matters beyond the image of one burning tank. It shows that the contest between protection and attack is now shaped by observation, adaptation, and the speed with which operators learn from each pass. And what makes the story even more significant is that this same logic was not limited to one immobilized turtle tank. It was also being used against Russian armored vehicles, still trying to continue their mission. The third phase of this battlefield pattern becomes clear when Russian armored vehicles are not attacked the moment they appear. Instead, they are watched from a distance until movement itself begins to expose weakness. That is what makes these encounters so dangerous. The threat does not always begin with an immediate blast. In many cases, it begins with surveillance. Ukrainian drone teams appear to follow armored vehicles patiently while collecting visual information about speed, spacing, direction, and formation discipline. This changes the role of the drone. It is no longer only a weapon. It becomes an eye above the battlefield, helping decide when a strike will matter most and where a vulnerable point is most likely to appear. That timing matters because an armored vehicle still has some defensive value while it is moving with purpose. A convoy that keeps its rhythm is harder to break than one that begins to hesitate. Once a vehicle slows, turns, emits smoke, or drifts out of line, the battlefield starts exposing it in a new way. The machine may still function, but it is no longer operating with confidence. In that moment, the drone operator no longer has to guess what the vehicle is doing. The target begins to signal stress on its own. A sudden stop can suggest a fault. A turn can reveal confusion or a blocked route. Smoke can point to damage, engine trouble, or mounting mechanical strain. Even a short delay can show that the crew is reacting to events instead of controlling them. That is why Ukrainian operators appear to wait for the instant when an armored vehicle becomes easier to read and easier to predict. A fast-moving APC is a harder problem. Its position changes quickly, and the best point of attack may not stay exposed long enough for an accurate strike. But once it slows or falls out of tempo, the balance shifts. The drone can close in with greater confidence and focus on a section that remains less protected than the rest. On field-modified armored vehicles, that often means the front, the edges around added shielding, or another area that remains partly open. Protective structures can reduce some attack angles, but they rarely cover every surface evenly. The act of reinforcing one section can leave another section more exposed during a turn, a stop, or an awkward movement through open ground. This is why one moment of disruption can quickly become a moment of direct danger. This reveals something important about how drones are being used in the current war. They are not only tools of destruction, they are also instruments of tracking, pressure, and selection. They watch how vehicles behave under stress, and they exploit the moment when a machine stops acting like part of a coordinated formation and starts acting like a separate target. In that sense, the drone becomes part of a wider system of battlefield control. It observes, waits, and then strikes when the chance of success has risen sharply. On this kind of battlefield, every pause carries risk. Every correction en route can expose another angle. Every sign of disorder can pull a vehicle closer to destruction, even before the final hit lands. That is why these scenes matter beyond one damaged APC or one disrupted convoy. They show that movement is now under constant observation, and that hesitation itself can become exposure. Yet drones do not always finish the job alone. Often they create the opening, reveal the weakness, and hold the target in danger long enough for the next layer of firepower to matter. The fourth stage of this battlefield pattern shows why a drone strike does not need to destroy a vehicle outright to become decisive. In many cases, Russian vehicles hit by Ukrainian FPV drones do not explode at once or burn immediately beyond recovery. Some remain partly intact. Some still keep enough armor to appear functional from a distance. But the first strike often achieves something more important than instant destruction. It reveals the vehicle's location, disrupts movement, and leaves the crew in a position that is far harder to manage under pressure. A machine that has been slowed, exposed, or forced to halt becomes far easier to finish later. That is why the drone attack should not be understood as a separate action. It is often the opening step in a larger process that takes a target from contact to complete loss. This is where artillery becomes decisive. Once a vehicle has been located and weakened, ground-based fire can take over with much greater destructive weight. The drone identifies, tracks, and pressures. Artillery then turns that damaged vehicle into a target for battlefield elimination. This coordination matters because Ukrainian forces do not need every drone to burn through armor and destroy a vehicle by itself. If the drone can expose the target, damage its mobility, or pin it in place, then heavier fire can do the rest with greater reliability. That makes the entire sequence more efficient. It also means that separate weapons are no longer operating as isolated tools. They are functioning as linked parts of one attack system. The logic is straightforward. Drone first, artillery after. The first layer creates vulnerability. The second layer sharply reduces the chance of survival. A crew that survives the initial strike may still face only a very short window before the next blow lands with much greater force. This matters because many Russian vehicles now carry added protection meant to reduce the effect of FPV attacks. Extra metal, outer cages, and improvised shielding can sometimes blunt the impact of the first strike. But those measures cannot solve the larger problem once the vehicle remains under observation. Protection against a drone does not erase the vehicle's position. It does not restore movement. It does not remove the danger created by follow-up fire. In that sense, added armor may delay destruction without preventing it. What appears here is not a single dramatic hit, but a multi-layer kill chain. The drone finds, fixes, and weakens. Artillery punishes a target that has already lost part of its battlefield value. That is why reinforced Russian vehicles can still end in complete destruction even after surviving the first contact. They are not facing one weapon at one moment. They are facing a sequence designed to close around them. And when this pattern is viewed in a wider context, it points to a deeper issue beyond Ukrainian tactics alone. It raises a question about the turtle tank itself, and whether a vehicle built to survive the drone threat can still survive everything that comes after. The turtle tank emerged as a battlefield adaptation to one of the most dangerous threats in this war: the spread of small FPV drones that can find armored vehicles quickly and strike with little warning. Russian crews responded with field modifications that changed the shape and purpose of the tank itself. Cage armor, sheet metal, outer frames, and in some cases jamming equipment were added to reduce the chance that a light drone could reach a vulnerable surface directly. The goal was practical. If a tank could no longer avoid detection from above, then it had to become harder to damage once detected. That helps explain why these vehicles often look less like standard combat platforms and more like moving protective shells. Their purpose is to stay alive long enough to approach the line, support an assault, or open space for other vehicles behind them. In that limited sense, the turtle tank does address a real problem. Extra external protection can make a small drone attack less straightforward. It can force operators to search longer for an opening, change their angle of approach, or use more than one strike to achieve the same effect. On a crowded battlefield, even a short delay can matter. A vehicle that survives a first contact from above may still reach a trench line or complete the first stage of a mission before heavier pressure arrives. That is why these machines cannot be dismissed as meaningless improvisation. They reflect a serious attempt to adapt under fire. In a war where cheap aerial threats can appear within seconds, even a brief increase in survivability can influence whether an assault reaches contact or collapses before arrival at all. But the same design also creates heavy penalties. The more a tank is wrapped in steel and framing, the more it gives up in vision and battlefield awareness. Crews inside lose a clearer view of terrain, movement, and danger around them. The problem grows further when weight and shape begin to affect mobility. Added metal makes the vehicle heavier, less balanced, and harder to handle in rough ground, mined areas, or narrow approach routes. A tank built to survive drone pressure may become slower and less responsive at exactly the moment when speed and control are most important. That means the turtle tank is not a symbol of clear advantage. It is a symbol of compromise. It shows how far the drone threat has pushed crews to accept less visibility, less agility, and less tactical freedom in exchange for a better chance of surviving the first attack. This kind of armor does not make the vehicle stronger in every sense. It protects one weakness while creating others. For that reason, the turtle tank should be understood as a wartime adaptation rather than a final answer. And once vehicles that have already sacrificed so much combat efficiency are still sent into larger assaults, they enter a battlefield where danger no longer comes from one isolated strike, but from a wider system of pressure that punishes every weakness they still carry. In large-scale assaults, Ukraine has shown that no single layer of Russian protection can solve the wider problem of combined pressure. FPV drones remain important, but they are only one part of the defensive picture. Artillery and anti-tank missiles add heavier force, longer reach, and stronger destructive effect against vehicles already under strain. When these systems are used together, the aim is not simply to destroy one machine at a time. The aim is to break the rhythm of an entire armored push, separate vehicles from each other, and turn one coordinated advance into a series of exposed targets. That is why reinforced vehicles can still be lost in large numbers, even after crews try to adapt. A turtle tank may have better odds against a small drone than a standard vehicle, but it still moves through a battlefield crowded with different threats arriving from different directions. If artillery strikes near the route, movement slows. If anti-tank fire threatens from the flank, crews become more cautious. If drones remain overhead, every delay becomes more dangerous. Under that kind of layered pressure, the value of extra armor begins to narrow. This is what makes the turtle tank more than a strange battlefield image. It represents a clear technological loop. One side introduces a field solution to answer a specific threat. The other side studies it, tests it, and adjusts tactics to reduce its advantage. The result is rarely permanent superiority. It is usually a brief edge followed by a rapid reply. In Ukraine, that cycle has become one of the defining features of the war. Adaptation no longer unfolds over long periods. It can happen across weeks, sometimes faster, as crews, engineers, artillery teams, and drone operators respond to each new problem. That is the deeper lesson of these assaults. Seen in that wider context, the destruction of a covered Russian tank is not just an isolated combat episode. It is evidence of a battlefield that keeps rewriting its own rules. Every new defense invites a new method of attack. Every protective measure creates fresh limits. And every attempt to regain safety must survive not only the first threat, but also the answer that follows soon after. From that view, the story of one armored vehicle being trapped and destroyed becomes a much clearer sign of how this war is changing at its core, from battlefield movement to battlefield adaptation itself. The turtle tank is not just a strange machine pulled from the chaos of war. It is a sign of how deeply drone warfare has changed armored combat in Ukraine. Russian crews added cages, metal screens, and other protections because the old model of survival no longer works. But this case shows that battlefield adaptation has limits. A vehicle may survive the first threat and still fail against the next one. That is the real lesson here. Modern war is no longer decided by armor alone or by firepower alone. It is decided by how quickly each side can observe, learn, and adjust under pressure. The turtle tank may look like a new answer, but it also proves how temporary every answer has become. The bigger question now is not which machine looks stronger. It is which side can turn the other side's latest defense into its next weakness in time. Subscribe to Military Force for more in-depth analysis of war, strategy, and global conflict, explained in a clear and serious way. The purpose is not to glorify destruction, but to help people understand how wars unfold, what they cost, and why their consequences reach far beyond the battlefield. Because the more honestly we study war, the more clearly we understand the value of peace and the importance of protecting it.